Welcome, everyone. It's Dr. Ramirez again, and today we're going to go over the basics and terminology of model based science teaching. We're going to return back to chapter two because in chapter two, there's some things that we need to cover. But this shouldn't take too long, and hopefully, it'll give you an idea of why we want to concentrate on models and why I chose this particular book. Um, here's a series of standards that are set up by the National Science Academy or Academy of Sciences. Uh, they were set up, on page 23 of that document. They were set up so that science teachers would know what it was that we needed to do in the classroom, and also what was meant by science inquiry. So we're going to go over these standards, and in a way, they define what inquiry is. It starts with making observations and posing questions. You see something, you want to understand what it is that you saw or felt or heard, with your senses. Also, examining books and other sources to discover what's already known. And then, once you know a little bit about the subject, plan investigations. You want to review what is known in light of the experimental evidence. In other words, not just those research articles that you might find in a science journal, but you also might want to hear what other people are saying from lay people and so on, just so that you can have a broader idea of the impact, because when we do science, we don't do it in isolation. Society has something to do with it too. And of course, using tools to gather and analyze and interpret data is something that we as science teachers need to give our students practice in doing. We also need to ask them to propose answers, explanations, and predictions. Sometimes you might ask them for a prediction, and it's the answer to you is pretty obvious. But when you ask the question to the students, or you ask them to kind of give you some answers for something, they quite don't give you the whole picture. In other words, not the true scientific explanation. And of course, we also need to communicate the results to others so that others can verify through their work the things that you came up with. Continuing, here is just an entirely a different standard that you might want to be thinking about, and that you are almost required as a scientist to use, and that's it. It requires the identification of assumptions that you hear, the use of critical and logical thinking, because you might see something, but you've got to go back and in an experiment and see what might have caused the results to be the way they did, and then also to consider alternative explanations. When we set up an experiment, it doesn't mean that we have taken into account all of the variables, and there may be other things that might be the cause of a particular phenomena. Um, in general, though, there are four dimensions of scientific literacy that we want students to leave the classrooms, and we're basically looking at from the time they enter school to the time they in school in K-12. But this is also something that I want for you all to consider for yourselves too. First of all, in this dimension, inquiry skills, and we have to understand what inquiry skills are. It's not doing an experiment. It's more than that, and hopefully we'll explain that in a little bit more. Learning science content is very important, but the content by itself doesn't have answers. And so we have to understand the nature of science, and we have to understand how science actually occurs out in the field where people are um, working. And I said the field. I also, when I mean that, I'm talking about the field of science, science inquiry, but also in laboratories, and sometimes not even in the field of outside of the environment or laboratory. Sometimes, and especially now, it's doing a lot of things with mathematical modeling. And then what I had alluded to earlier in this particular conversation is the ability to view science as a greater social, in a greater and social and personal context. We don't do anything in science in isolation, and sometimes we think of things that we would like to do, but uh, there are just some things that we can't do because society does not allow us to do it. So we have to keep this in mind and always understand where our place is in the science and social community. Um, Here, what we're going to do is kind of look at the differences between inquiry and traditional science programs. I should have put inquiry on one side and then the other if I wrote it that way, but traditional is probably the way most of us see it, so I put it on the left hand side and inquiry on the right hand side. So let me go over traditional. Uh, Content comes before the activity. And in inquiry, the activity leads to the content. It's just an entirely way of looking at that. Uh, Content, in a traditional sense, is information. In other words, a definition. But here's where I think a lot of lay people and people that are not in science don't understand that really in inquiry, content is concept focused. It's in our mind. Um, Activities confirm the content. And really, in inquiry, its activities lead to the discovery of content. And that's how we learn things. If we always just talk about science from a textbook, then what happens is we're never going to discover anything new. It's going to be only what you read. And in inquiry, the activities lead to the discovery of content. Also, in terms of the student and the teacher, the first thing is there's little student involvement in the planning. And in inquiry, some or much of the involvement is of student involvement in the planning. And in traditional, it's heavily teacher directed. And I misspelled some. Some teacher direction in inquiry, just so that students don't, cause an explosion in the classroom, or redirecting the student toward finding answers. The focus on traditional classrooms is to obtain answers, and the focus in inquiry is to focus in part on the process. How did you go about doing your activity? In traditional classrooms, the emphasis is on developing physical technique. Oh, learn how to create a wet slide, or how do you, conduct or set up a transect or something like that. But really, in inquiry, the emphasis is on exploration and inquiry, finding things out. Um, I don't even know what the heck that is. um, is SOG. Let's see. Let me see what that really meant here. Okay. I hate when I misspell things. I was doing this rather quickly. Okay, so there it is. Saying little about the nature of science. I should have remembered that. And really, in inquiry, it partly mirrors the nature of science because we're working like a scientist would, and then provides little context for science, and inquiry provides some context for science. Those are really important parts of the differences between inquiry and traditional science classrooms. You can go back to your book now that I found the page number. It's on page 53, and you look at those lists there. They're listed there in table 4.1, and you can look through that and then just rationalize that. If we really think about science, uh, science really starts out in at the elementary level with what we refer to as process skills, and these that are listed here are the basic science process skills. You probably have heard a lot about them, either in your science methods class or in the curriculum that you have in your school district, and of course the state curriculum also makes reference to these. Observing, measuring, inferring, predicting, and communicating. Those are the basic things that definitely K through 5 students should be able to do. And but we want to go a little bit further because actual science uh, looks more at the integrated process skills, and the integrated process skills are these skills that are beyond the basic. They're things like formulating a hypothesis, and this is a mind thing. This requires for the student to be able to think of what it is that they are going to be researching and how they think the outcome of that research is going to be, just so that they have this idea of where they're going. They have to identify the variables, and have to sometimes define the variables operationally, because sometimes you don't have definitions that you can take from a textbook in a real science activity, in science inquiry activity. You have to create the definitions for what it is that you're observing, and you have to describe the relationships between the variables, one variable versus another variable. How do they compare? How are they different? What are the relationships between one and the other or others? Then you have to design the investigation and conduct experiments. Then we concentrate, and you see, you don't have this in the basic process skills, is acquiring the data. In other words, how do you set up the apparatus so that you can convert what it is that you see into numbers that you can then put together and analyze. And to analyze it, you sometimes have to organize that data in tables and graphs, and then know a little bit about statistics so you can analyze the investigations and the data, and then try to understand cause and effect relationships between something. And then, of course, and this gets left out, and that's what this course in this book that you're reading is really all about, and that's formulating models. And in order to formulate models, we need to look at how models are basically put together. And so here's where I'm going to go back and ask you all to reference page 12 in chapter 2 about how inquiry, how it looks like in a model based science teaching framework, and you look at it, and the whole idea is that you come up with a problem out in out in nature, and then uh, you inquire, you try to figure out, well, where is it, what's the solution to this problem. And so you inquire, and then you go through some inquiry, and either it's from books or from little things that you're trying to manipulate, and you discover things. And in your mind, you are developing a fleeting model, and we'll talk about mental models in just a little bit. But this is in your head. This is it's something that happens right, in your brain, and then from there you develop a concept of what it is that you are observing. So you had the problem, you checked on it, you discovered some things, and this may be cyclical, and I'll show you that in another slide. It may be cyclical because you may be going through this several times in your head to come up with what it is that you think you're seeing. Then you add the enrichment, you read other articles, you talk to other people, and so on. And then, you apply that reasoning in some sort of study. And that's how, in general, the inquiry works in the MBST framework. But let me go a little bit more on this idea of modeling. Um, uh, you look at things like mental models, um, and it goes back to what I was just talking about. You see that observation. Remember, we saw something that was a problem. I go back. Okay, whoops. You saw something that was a problem, and then it went through all of these steps. So what you're doing here is you got this input. You now have in your body all types of receptors, either receptors in your eye, receptors in your hand, receptors in your taste buds, just, all of these observations that's coming, and they get to your brain. And when they get to your brain, then you start assembling all of that information, and you start processing it, and you develop what they refer to as a streaming mental model. And you start developing these conscious images. You don't even know exactly, you haven't even organized what that information looks like, or what that concept is. You just know you're getting all of this information, and it's going round and round and round in your brain. That's why they refer to it as a streaming mental model. And you're becoming more and more aware of what it is that you are actually looking at, and or sensing. And that eventually goes to what's referred to as conscious awareness. But it has nothing to do yet with anything physical. It is all mental. And we do it every day. You're doing it right now. You're hearing me. Here's the input. I'm giving out voice, vibrations. They're going through this computer that might be physical, but then the thoughts that are coming to your mind right now are those thoughts that take those vibrations in your ear, what you're seeing on the screen right now. You're processing it and you're going over and over it again, and you're listening for words so that you can eventually say to yourself, oh, I understand what streaming is. I understand what a streaming mental model is and how it's connected and assembled to form conscious images. And then you say to yourself, oh, that's what it is. That's that conscious awareness. And that's how modeling crosses over from, something that's physical to something that is mental. Here's something that we want to look at, and that is getting ready to have students understand what these phenomena are so that they can be ready to make decisions or to understand the concepts that they have. So here's the results of learning through the model-based science teaching approach and why it's advocated. First of all, you'll know how to create descriptive or explanatory models of phenomena through inquiry. In other words, you're going to be able to tell someone simply, distinctly, what it is that you are seeing or experiencing in scientific terms. And then you're going to view science as the construction of descriptive and explanatory models. So all of these models out there in nature or in the laboratory, you're putting together and making this construction. And there was a question that you all worked on in a previous chapter. You're going to distinguish science from technology according to the purposes of each. And so, there's a way of thinking of science and a way of thinking about technology and how the two relate. Sometimes it's very difficult to separate them, but that's the whole idea for you all to be able to do that. Also, you need to understand learning as the creation of mental and express models. So that's what we'll work on. We'll work on you developing that mental model about, developing a curriculum using a model based teaching approach. Then you're going to understand that knowledge is a variable structure of simplified mental models. Uh, that's human nature. Whenever you see something and you experience something, the thing your mind tries to do is it tries to simplify it. For me, it has to simplify it a lot because I'm not that bright. So you gotta make it real simple for me so that I hear the description that's being given and I understand. Or in my mind starts making things simple so that I can begin to understand it. And it's not just one simplified mental model, it's many simplified mental models. And I start putting these things together. And that's why The last one on this slide says to understand the subjective nature of knowing and learning. You see some things, you try to understand them, you make those connections. Sometimes that doesn't quite fit. You go back and then do it again until you think you have a better understanding of what phenomena you saw. So it's something that's a difficult process, but it's something that we all do. We do it all the time. Then the last two is you have to know the difference between scientific and non-scientific model building. This is something. I mean, I'm not. You're going to take a test on, or you took a test this last uh, chapter uh, about identifying what was scientific and what was non-scientific. Well, for instance, and I didn't put the example, but I'll tell you all right now. The example has to do with, creationism. We don't teach it in our schools today because it is not a science, uh, a pure science uh, activity. It doesn't have results. You cannot collect data on creationist principles. Or even if some people have tried to change the term from evolution to creation to art to what was it, intellectual design. Okay, uh, the intellectual design saying, "Oh, there's more logic to it. There's more information. We're looking at data, but really, it's still a pretty large leap to say that you can disregard evolution based on those two approaches to gaining knowledge, just because it is a non-scientific model." And then, of course, the last thing is to understand on a practical level which science can never explain. Understand on a practical level why science can never explain all things. So even going back to evolution is always going to have holes because it is a theory, and theories don't have all the facts. Whether it's the cell theory or atomic theory, we're always learning new things. And because of that, we can never explain everything. When we see something small, then we see it even smaller, and we see it even smaller. We know that when the right tool and the right technology appears, we'll see it even smaller, and it will continue to be that way. So uh, that's a way of looking at that practicality of science in that way. Okay, here we're going to talk about extending students for readiness. Now, I'm not going to go into how you teach a student MBST at the elementary, middle school, or high school level. It's in the book. I'm going to let you all read it. But what I will do here is, regardless, you have to develop an understanding of these things at some point or another. And of course, as I mentioned earlier, from kindergarten all the way into graduate school. So here they are: how humans learn by constructing mental models. That's the nature of learning. That's why I spent quite a bit of time earlier just talking about that part. The nature and limitations of express models, the principles of communication. You cannot explain everything, either because you don't have all of the information, or at this time you don't have the right terms or the right concepts to give an explanation. And the process of building models in science, you have to understand that scientific investigation and learning is ever changing, just like your thought is ever changing. And the difference between scientific and non scientific models. Even though I gave the explanation of evolution or creationism or cell theory, it might not fit the way of thinking, either because of more social reasons, but from scientific points of view, we have to understand that there's a difference between looking at science and non-science that way. Okay, so as we end here, I want to make certain that you all have an idea of what you're going to need to get ready for in this particular chapter, and read carefully how um, MBST can be looked at the elementary and secondary level, and look very carefully at the lab, at the example of MBST that's going to be given to you all in this chapter. And I was trying to figure out how you could do check the density of cereals, but read through it. I mean, I had to go through some some thinking about this thing, and then of course can concentrate on. This is new to students. Concentrate on how is it that you're going to introduce your students to model-based science teaching approaches, and look very carefully at the at science and other ways of looking at it, and how to develop lessons that fit this particular model. So make certain that this idea of learning through models is fits very well with the national science standards, but it also fits very well with what school curricula have. At this point, I want to tell you all goodbye, and if you all have any questions, please email me. Take care.